All right, as we're getting ready to finish up chapter 9, I just wanted to do a little recap of where we've been in the last 3 chapters, try to get the big picture. So keep in mind what we've done so far. We started all the way back in chapter 7 with confidence intervals and sample size calculations. So both of these columns right here we're chapter 7. We started with just a single proportion. We said we can find the confidence interval, we can compute a sample size. And then we did means, and then we did standard deviation or variance. They kind of get the same thing. And then in chapter 8, we said we can also go on and test somebody's claim. See if they're lying to us. So we did hypothesis testing about proportions and means and standard deviations. I feel like we should have some nice check marks in here. So let's just say we learned that, we learned that, we learned that, we learned all of these. Then you mastered these guys. And then we moved on to chapter 9. And chapter 9, so all of this stuff here is chapter 9. And in chapter 9, we just basically did the same ideas, but we said let's compare 2 groups. So we looked at comparing 2 proportions and doing a hypothesis test and also a confidence interval. And then we looked at comparing 2 means, and we did them when the groups were independent. And we also did them when you had matched pairs, and you looked at sort of the differences, not the individual lists. So you looked at list 1 minus list 2, sort of make that third list. So we're on the very last thing, which is comparing 2 standard deviations. And today we're going to learn how to do a hypothesis test. Our book stays away from confidence intervals in this particular section. We've actually got the ability to do that. It's built into StatDisk. But there's a reason why they're staying away from confidence intervals, and we'll talk about that. But for the moment, I'm just going to say all we're going to look at today is doing a hypothesis test to see if the standard deviations of 2 groups are the same. And I think we're pretty familiar with the drill, so let's just jump right into an example. So this is number 12 from the homework. This is skulls from 4000 BC and from 150 AD, so a little more than 4,000 years apart. And they want to see if there's a difference in standard deviations between these 2 groups. Well, let's read what they want to see. I should make assumptions. So use a 0.05 significance level, and let's get in the right layer. Use a 0.05 significance level to test the claim that the variation, keep in mind variation is just a general word that talks about standard deviation or variance. In general, how spread out they are. That the variation of maximal skull breadths in 4,000 is the same as the variation. So is the same. Right, is really our key word there. So their claim is that the standard deviation for the first group, which I'll make that the 4000 BC group, is the same as standard deviation from the 150 AD group. Okay, so the same, and then the opposite claim would be that they are not the same. And we get the one with the equal sign to become the null. The one that's saying they're not equal to be the alternative. And we're ready for a p-value, so we are ready to go to StatDisk. Let's see, we have a 0.05 significance level. Okay, so let's pull up StatDisk. And under analysis, we want to go to hypothesis testing, and down there at the very bottom of the list, we've done this entire list now. Down here at the very bottom of the list is the standard deviation comparing 2 samples. So pick that one. As usual, the first thing they want to know is what's that alternative hypothesis, which for us, the alternative hypothesis was that they're not equal. So population standard deviation 1 there is not equal to population standard deviation 2. Yep. Significance level is 0.05. The sample size for the first group is 30. And the sample standard deviation for the first group is 5.13. The sample size for the second group is also 30. There's no reason they have to be the same. They just were this time. So sample size for group 2 is 30, and their standard deviation is 5.35. Those seem pretty darn close to each other, by the way, but in statistics, it's not about seeming pretty darn close. It's about crunching the numbers. So let's go ahead and evaluate this and take a look at the p-value. And the p-value, yeah, is pretty big, 0.823 to 3 decimal places. So p is equal to 0.823. So if the null is true, our samples are not unusual. So we can't reject the null. We are failing to reject the null. So when you fail to reject the null, that also means I can't accept the alternative, and that's how I'm going to write my sentence. I'm going to say there's no evidence. Sorry, that's the alternative. No evidence that the variation in maximal skull breadths no evidence is different. From 4000 BC to 150 AD. Boom. Done. And that's pretty much it. I think you are hypothesis testing wizards at this point. You know what you're doing. The only thing that's a little bit different, of course, is they will sometimes give you the lists of data, not the summary statistics, and you know how to handle that. You'll just type the lists into list 1 and list 2 and say, hey, the columns are list 1 and list 2, and you'll be set to go. So go do the last homework from chapter 9. It's the second to last homework in the course. And no, I know. I'm sad too. It'll be all right.